Excited to do another one tonight with you all. Thank you. Um, Many of you have talked with my co-founder, Quinn, at these. He is really disappointed he can't be here. He has COVID. So no matter what, you will have a better night than Quinn. But he is truly bummed to miss tonight's conversations. He's been looking forward to these for a while. Before we get started with some logistics, I first wanted to do a shout out to our wonderful host here, Vappy. This space is incredible, and many of you, of course, are familiar with the Vappy platform. I'm just going to toss it over to Nikhil.
Thank you, Nina. Thank you, everyone. I'm a little nervous, sending in a lot of people. Did not expect this turnout. I don't know if you did, but that's insane. The community has grown so much. Yeah, thanks everyone for being here. I just want to also thank Daily and Pipecat for organizing this event. There have been like community builders since like day one. When we were building Vappy, like the first people we went to is like Quinn and Nina. So it's just really touching to see the community prosper and grow. Yeah, I hope you enjoy the office. We are really enjoying it. We've got lucky with the space, and looking forward to hosting more events. Obligatory call out that we are hiring. We are growing aggressively, as you can imagine. Need to fill the space. So if you are looking and out there, and if your friends who are looking, come find me or Nikhil at Vappy.ai, founders at Vappy.ai. But yeah, looking forward to the event. Thank you,
Great,
Nina.
thank you. I can't say enough about the Vappy team. We've been working with them for a long time now. Some of the best technology in the space, some of the best humans too. So yes, what roles are you hiring for? Just everything across the stack?
Yeah, just I'll take anyone you can give me, just everywhere. Anyone, just give me anyone. Yeah, ops, sales, growth, DevRel, backend, infrastructure, Kubernetes. Yeah, anything. Yeah.
Great, excellent. So it's Nikhil at Vappy.ai or founders at Vappy.ai. Check it out. It's one of the fastest growing teams in voice. Logistics, Wi-Fi. You all can join the Vappy Wi-Fi network. The password is written in tiny, tiny, tiny script on the whiteboard in the back. It says, voice is life. So that's the password. Vappy, voice is life, all one word, lowercase. There's water and pizza here. Please enjoy. The Vappy kitchen is off limits unless you join Vappy. So another reason to apply and work at Vappy. But for tonight, the Vappy kitchen is off limits. So thank you for not going in there. The bathrooms are through the back. The women's room is right before the kitchen. To get to the men's room, just keep walking all the way back. Make sure the door is propped open, the hallway door back into the office. Otherwise, you'll be locked out. Knock loudly and we will come retrieve you, or just make sure again that the door is propped open if you head into the hallway to go into the restroom. And of course, it's a meetup. So there is swag. I think there's some Pipecat t-shirts out, some Pipecat stickers. Grab some and enjoy. Lily from Rime is here to talk about the new model, which we're super excited about. Plus Sean DuBois from OpenAI and Aleix from Daily and the Pipecat community. So I'm excited to get right into the conversations. To get started, I'll just mention a really fun one. Quinn wrote a book. There's a stack of them on the table over there. It's Voice AI and Voice Agents, an illustrated primer. It distills all our learnings from the last year of what's been going on in the space. Really touches on a lot of the things we've discussed in these meetups. So check it out. We will be publishing it online, of course, inspired by Sean's WebRTC for the Curious, which I'll talk about some more. So you'll be able to find it online. We have it in PDF form if you prefer that, but we also love print. So if you also love print, just make sure to get your copy. And when you open up to the contributors page, you'll see, in addition to Quinn's name, um, the name of everyone who's contributed to Pipecat, our open source framework. You all are part of this book and part of the learnings of Voice AI. So thank you. We're excited by all that. Let's see if there's anything else to mention about logistics while I check my notes. If anyone has anything to say, do raise your hand. I think I covered everything: Wi-Fi, drinks, t-shirts, restroom. Great, let's just get into it. We're joined tonight by several architects and senior engineers in the community, which is super exciting. One of them is Mark Backman, our VP of Product at Daily. Mark also leads the efforts around Pipecat. He and Quinn have worked together for several years at Quinn's last startup. And when Quinn started Daily, Mark was one of the first people he reached out to join the team. So I'm really excited that Mark is in from Atlanta to sort of just be part of the community tonight and also lead our conversations. So I'll just turn it over to you, Mark.
Great. Thanks, Nina. There's a lot of people here. This is great. One sec. So before we get started today, just a quick announcement. So obviously, if you've built with Pipecat, you've probably found some of the rough edges in building with Voice AI, and but we're going to talk about this with Lily. Voice is really the UX. So something we've been working on, a fun project we want to announce, a new open source project, is around turn detection. So one of the kind of the hairiest or most difficult parts is figuring out when a human is done speaking. When do you let the bot come in? And if you've built anything, you've definitely seen this, where you set your VAD to half a second because you want it to respond quickly, and you take a second to think, and it butts in. So what we've been working on, this is the start of an effort, so it's not the end, is a new context-aware turn detection model, excuse me, that gives you the ability to figure out it gives you the ability to figure out when someone has done speaking. So this model will emit some type of yes, no for complete thought. And it's something you can use in your model, in your voice cascaded pipeline, to determine when to actually let the LLM interrupt. So it's something we'll post somewhere, maybe, I guess, tomorrow. This is an early announcement. But effectively, it's something that we want people to contribute to. It's built off of, I think, something like 4,000 samples, and it's something that we want more of the community to contribute. So take a look at it, see what see what you think, give us feedback, and help us build more for the future. So that's something that's new and exciting. We'll have more to share. All right, I'm going to introduce Lily from Rime, Lily Clifford. She's the CEO and co-founder, and joining me for our first conversation tonight. Let's give her a round of applause. Okay.
Thanks for coming, you guys.
Yeah. Well, why don't you start out, just tell us who you are, your background, fill us in.
Yeah, so prior to founding Rime, I was a PhD student at Stanford in the linguistics department, working on computational speech problems, and working with really diverse data sets, essentially, right? Like low resource language, speech recognition, sociolinguistically aware voice biometrics, classification problems. And about 2019, 2020, I got really into research around speech synthesis. And a lot of stuff was happening that I think we didn't see reflected in innovative products until probably like 2023, around that time. I got together with my two co-founders, Brooke and Aries, and we started, it sounds really kind of silly, honestly, but it's been kind of the basis for a lot of the work that we've done from a product and customer discovery perspective by building a recording studio, like 7th and Market. And slowly but surely, kind of just grunt work, honestly, like collecting one of the largest, if not the largest, proprietary data sets of this duplex speech data. So someone who comes in, right, like talks with one of their friends or family members, in some cases one of us, and we're just working 12-hour days collecting this data set. And in the meantime, right, I was like still trying to do my PhD program, very unsuccessfully, I might add. So I dropped out. at the time that I was supposed to be writing my dissertation proposal and just started running customer discovery. And this is, again, like the era we're talking about is like 2022, 2023. This is before ChatGPT. And what customer discovery looked like at that point, right, is like talking with people who are building IVR systems, right? And it's like, what would it mean if you had a better voice than what you have right now? And so we were trying to solve for that problem, right? Like, and we were training models on the basis of this data that we were collecting. And it turns out training text-speech models is really hard. And so the first iterations weren't very good. And also, like, at the same time, by talking with folks who are building these really high volume calling applications, we were starting to understand, like, what are the problems that they're trying to solve for that we didn't anticipate, right? Because, like, of course, they wanted a better quality voice. But, right, like, they were being like, okay, well, what happens if it mispronounces this word? And we were like, oh, I don't know, that's a good question, right? And so what we learned very quickly, right, is that a lot of these problems that crop up when you're building one of these applications have nothing to do with the quality of the voice or the latency of the model, right? Although those are very important. But in solving for a lot of these last mile problems that crop up when you're, right, building a food ordering application, say for Domino's and Wingstop and Blake's Lottaburger and Whataburger, right? And you're being like, okay, what happens if the bot doesn't pronounce, you know, Whataburger correctly? And it's like, we can't ship that to our customer, right? And so those are some of the problems that we started solving for. And I also have to admit, right, like this being before ChatGPT, I had no idea that like 95% of the volume that Rime is currently serving are applications that didn't exist 2 years ago, right? So like really sophisticated outbound calling applications, role play simulations for, you know, really high stakes contact center training applications, LLM-powered fast food ordering at the drive-thru, right? Like these are applications I didn't know were going to exist. I was kind of building for like the IVR system, and it turns out, right, like people who are building IVR systems are kind of behind on the technology adoption curve, and so that's kind of the long and short of it, right? Like for what it's worth, I didn't even know the acronym IVR when we started building a couple years ago, and now we're powering tens of millions of these phone calls every month, and so it's been really exciting just to be a part of the community as everyone's building and learn from each other because, again, right, like when you're teasing this open source turn completion model, right, like these are problems that a lot of people don't think about, right, but that are critical to building these applications. And that's really, I think, the central part of Rime's thesis is like, what is a compelling application? It's one that works, and making it work is something that requires a lot of hard effort.
Yeah, and we were talking just before how it is really interesting when you think about it. There's all the technology that underpins it, but at the end of the day, it's really about building, like designing conversations and building trust. And if you can't pronounce a name right, it really goes out the window. So it is something that does take, you know, a lot that goes in there. So I do, just to maybe lean into what you mentioned, something about the last mile. Like, how do you approach solving? Because it's, you know, there's just so many complexities in ensuring you get all the way there. What goes into ensuring that you have like a great solution in terms of, you know, what you're shipping to solve some of the problems you mentioned?
Yeah, so like it used to be when you were training a text-to-speech model, you were training the text-to-speech model not on, right, like the letters, the pure letters that someone would be sending you to your API, but on phonemes, right? The phonemes are the underlying phonetic representation, so something that you might see like in an international phonetic alphabet. And so Google, Microsoft, and Amazon, these are tools, right, that are in some sense, right, like built for this problem in particular, right? Like we anticipate that there's words that didn't even exist at the time that we train a model. So how can we anticipate that the model will pronounce it correctly? Well, we train on phonemes at training time such that inference time our customers can specify a custom pronunciation for a word. And I think, right, like in a lot of ways as our models have become more and more sophisticated, we've gone away from this controllability aspect. And so kind of as a joke, I proposed this thing called the Sbarro Index. I don't know if you guys are familiar with this restaurant.
The pizza place.
If
you're from New York.
Yes. They have like 700 locations, something like that. And I think experiencing some business problems, but regardless, a lot of locations. And if you were building a voice ordering application for Sbarro with, right, like 700 applications, 700 locations, right, like 100 million plus in revenue, you can't use a lot of the leading text-to-speech models on the market because they can't pronounce Sbarro correctly. So it's like approaching that problem is sophisticated because, right, like out of the box, the model should be able to pronounce every word. That's of course an impossibility. So then the goal becomes, right, like how do you build developer tooling that makes it really easy to solve that problem when, right, like the folks who are building the voice ordering application for Sabaro aren't linguists themselves. And so oftentimes what we're thinking about is like, how do you frame this developer problem as sort of a linguistics as a service problem? And right, like on the Rime platform, you can just go in, record yourself saying the word Sabaro, and then we can tell you, right, like here's the phonemic representation for that word. You can use SSML to hit our API. And then of course, right, like the goal should be that we cover more and more words moving forward. But I think the first step is just being transparent with our users, like, hey, we're not gonna pronounce every word correctly out of the box.
But it sounds like you're working towards solving a lot of these really important problems. What do you think that looks like getting all the way there? What's the developer tooling, and what do you unlock, I guess, by getting to the point where you've solved a lot of these last mile problems and you have things done? What does the world look like then?
I mean, I think, right, like we should always be approaching this from a perspective, right? Like how do we help developers make really compelling applications, right? Like all these net new applications are themselves a lot more compelling than the IVR systems of even like the present day. And so I think a lot of us are attuned to that. Then the goal becomes, right, like how do you create a delightful experience, right? And so like we were talking with a customer the other day where the problem for them is this, right? Like we have a large CRM, right, for this phone system. We know that when the bot says the customer's name when they call in, like, hey, thanks for calling, Lily, that CSAT is meaningfully improved, like significantly. At the same time, right, like how do we know that we know not every name is going to be pronounced correctly. That's just the reality. And so then the goal becomes, right, like how can you help us by telling us, like, here's our confidence about how correctly your system can pronounce the name, such that when there's high confidence, right, we say the name, and when there's low confidence, we don't say the name. Because it's worse in the 10% of the cases where we mispronounce a name, it's way worse than the 90% where we increase CSAT. It's not worth the risk. And so these are last mile problems. They will remain last mile problems. And I'll give you a reason why, right? Like we have a customer who's like, hey, your guys' system is mispronouncing this name. And we ask, what's the name? And they're like, oh, it's Alicia. I'm like, oh, that's a pretty important name. We should be pronouncing that name correctly. And then they send it to us, the text. I'm like, oh, I thought I would pronounce that Alicia, right? And so then the question becomes like, should we maintain a list of these, right, like phonetically ambiguous names? Probably, if we want to solve this problem of saying a name. So that we can like use this API that I just mentioned to give, right, this phonemic spelling for a name by asking the customer, right, like, is your name Anna or Anna or Alicia or Alicia? So that's just one example, right? Like, but I think the finishing touches here, I think like the really exciting stuff too.
Yeah. And as a human that's been on the planet for 42 years, I've worked with Aleix there, but I'm always calling him just Aleix because I just can't. My English pronunciation is just terrible. So it is a constant problem, even just day to day.
I'm compelling all of you not to go to the Rime.ai dashboard and try and see how we're pronouncing Aleix, because I guarantee you it's not correct.
It's challenging.
Yeah.
So I want to throw out some hot takes here.
Okay.
So we build a lot. Well, we work with a lot of customers building, and when someone is new to voice AI, one of the first things I hear is, why do I need, Pipecat, if you built with Pipecat, it's an orchestration framework if you haven't heard of it. Why do I need that when there are speech-to-speech models? Can't I just hook up to these models? And they are fantastic. We're going to spend some time talking about it. I do think speech-to-speech is going to be absolutely critical to the future. It gives you just the ability to have full emotional representation end-to-end in the pipeline. But what do you think about that? So as a text-to-speech provider, where is your worldview, and how do you square against that? Because I see certain things that are challenging with the current state of speech-to-speech, but where do you land on that?
Yeah, I think like as an ML engineer, I would never bet against end-to-end learning. Like anyone who bets against end-to-end learning is in for disappointment year after year for a very long time. And at the same time, right, like what I just said about the phoneme layer to training these text-to-speech models, that's an example of where like we've learned that text-to-speech in some cases works better by not taking an end-to-end approach, right? Like Andrew Ng, who's like, I just deeply respect, right, like had very early work on fully end-to-end speech synthesis called char to wave, like character to wave. And now, like, I feel very vindicated because he's posting on LinkedIn about some of the shortcomings of the fully end-to-end speech-to-speech models. And some of those are just, right, like reasoning capabilities are reduced, right? Like goes without saying that like the information contained with speech is a lot richer than that contained with text, right? So it's harder to learn these kind of longer range dependencies and meaning. I also think for the customers that we serve, where like business logic becomes really important, and again, I'm not trying to be like totally pessimistic here. I think like the future is definitely in which there's both these end-to-end models, maybe in consumer products, right? Like, but when it comes to like highly regulated industries, large high volume customer support channels, I don't see these cascaded systems going away anytime soon. And for that matter, right, like when I hear a call, when I hear recordings that customers send us of a call that went particularly well, calls that are powered by Rime, right, like the person on the end of the phone isn't like, hey, by the way, is this a speech-to-speech model or a cascaded system? I mean, oftentimes they A, don't know that it's a bot that they're talking to, and B, right, like they just care that the application is good. And I think as ML engineers, we can overly focus on these end-to-end approaches because they're really impressive. I would never say that they're not impressive, but I think for a lot of applications that, at least today, they're not suitable. And for that reason, I think we're pretty firmly focused on solving a lot of these problems in just text-to-speech, for sure.
Great. I think we have time maybe for one more. I'm very interested. We talked a lot about training, but I don't know if we have enough time to get into that. I know that there's probably pressure, maybe in the hot takes category also. A lot of the text-to-speech providers also seem to be falling into the speech-to-speech or agent realm. So I guess where do you view that, and specializing in TTS versus going, trying to deliver something to end users or end developers as a low-code solution?
Yeah, I think, right, like from our perspective, the goal should always be, right, like how do you deliver value to the end user? And if that end user is a developer of an application, today, like I think Quinn when I chatted with Quinn about this, he was like, "Can I get you on record as saying Rime will never ship an agent?" And I think maybe that's overstated, but I also think, right, like there's so much that we can build to deliver value based on the models that we've already trained, right? Like A/B testing harnesses for determining which voices are suitable for which, right? Like in the case of fast food ordering, right, we've shown that, right, for example, when someone's calling Wingstop and they hear an African American English voice, the likelihood of that call succeeding increases by 15%. Right? Like I want to build the tool that allows those insights to, right, like be something that can be built upon, right? And I don't think we need to like ship a single API that strings together the LLM and turn detection and VAD and TTS and ASR to like capture more value within the stack. And I think a lot of times that's kind of what the play is. But for us, I think we're just so much more interested in building, tooling that allows to build more compelling applications, not necessarily like one that's controlled by us, I think is how I might put it.
Great.
Awesome.
We don't have time for questions, but we do have a lot of time for networking. And
awesome.
There's probably, if you're interested in anything about how they're training or what the APIs are like, or just learning how to get started, why don't you grab Lily after? So thanks so much.
Yeah, thank you so much, you guys. Yeah, really pleasure. Thank you.
All right. So next we have Sean DuBois from OpenAI and Aleix Conchillo from Daily. And I'm realizing we're going to have to, we just have 2 mics, is that right? Okay. Why don't I sit in the middle?
Yeah.
I can pass the mic around.
There is a wide mic there.
Oh, do you want to do that?
Yeah, let's do that. You want to grab that?
I was going to say, when I go to Starbucks, I'm just Alex. 'cause
He was
it's much
Alex
easier.
today.
I'm
We
just
went to
Alex,
to Andy's, and he's like, "I'm Alex." I was like, "Oh,
I'll
that's a
talk to Lily and see
that's a
if
good
she
idea.
wants my name.
Maybe we can solve this problem." So just to get started, so these two, I've worked with Aleix for, I don't know, 13 years, so I've known him for a long time. I met Sean for the first time today, but he is a legend in the WebRTC community as the creator of Pion, which has had tremendous influence on a lot of companies. So I'm going to let the two of these two folks introduce themselves. Why don't you get started, Sean?
Cool. Hey, I'm Sean. So I started in the space with Pion, which is like a pure Go implementation of WebRTC, and the world was a very different place at the time. People only really cared about conferencing, and they would say like, "Oh, I want to build this custom thing. Like I want to save videos," and it's really hard to do with like pre-built servers. So when I started down this path, it was like very different, and I watched the world, I watched so many things change. That COVID happened, and like everyone got really excited about, like WebRTC was not cool in 2017. Like I worked on it because like Snowflake was doing Tor via data channels, and I thought that was super cool that like two browsers could get around firewalls and blocks and stuff like that. And I'm like, I just got obsessed with, you put this open source out there and people use it. And then I saw conferencing get big because of COVID, and then I went and did WebRTC broadcasting, so you could do like, instead of like 3 seconds of delay, 200 milliseconds of delay, and all that meant that you could like talk to your audience directly, and that was super cool. And then all of this stuff is brand new as well. So and now like I hope we get a chance to talk, like WebRTC is coming to microcontrollers, and so now you can have like this little $10 board that's like this size, and you can have, and I did a demo of putting it into a toy, so you can have like a child's toy that can sit and talk back to you. I guess it's roundabout to say, like I just love building this stuff. It's so magical. It feels to me it's like being an OS dev in the 90s where like everything was moving so quick. Like WebRTC, I get to see the whole world, and it's super fun. So I don't know if I answered the question. I just talked about how I like WebRTC.
Yourself,
yeah.
so.
Oh, and then like I work on this other thing called WebRTC for the Curious. So if you want to know how WebRTC really works, it's like this open source book. It's all on GitHub, and you can see like how the protocol work. It kind of answers the why this problem needs to be solved, how it's solved, and it also talks about the history. I like went and like WebRTC has actually been around since the 90s, and I went back and interviewed like the people that worked in RTMP and ICE and stuff like that. So yeah, that's what I'm passionate about.
I guess just a question here before we get in, because there will be a fair amount of WebRTC. Sean told me, he said, I just want to talk about WebRTC. This is a Voice AI meetup, so we'll find a way to tie it in. But who has familiarity here, like on a technical level? Just maybe a show of hands with WebRTC? Okay, so a fair amount. This actually represents, I think, the community we work with in Pipecat, too. So I think we'll tie it in and maybe provide some education. Aleix.
It's not Alex, it's Aleix. It's a Catalan name. I'm originally from Barcelona. And yeah, as Mark was saying, we've worked together since I moved to the US back in 2011, I believe. Did a bunch of video streaming when I moved here, used WebRTC, but not in the browser. We use it for a lot of different purposes. And now I work at Daily, and for the past year, I've been working on Pipecat, which is this orchestration framework for Voice AI, which I guess all you guys are here for Voice AI. So that's, apart from WebRTC, we'll talk about that as well. How many people use Pipecat or know about Pipecat? Ooh, good. That's good. Well, yeah, I'm super excited because I know a lot of people from the Discord channel, like Dan here and other people, and yeah, super excited to meet you all, and we can talk later if you guys have time.
Great. So maybe just as an entry point, one of the big things we see a lot in Pipecat, we have all sorts of transports. You can connect via WebSocket, via WebRTC. So I guess it is, I guess, an interesting point to maybe delve into WebRTC and to, maybe Sean, for you, where are the strengths, weaknesses, comparisons to WebSockets? Because I see all day long, hey, WebSockets work great on my server. Why can't I connect to a client? And then 3 days later, why am I getting choppy audio? So, I mean, maybe you can dive into that and give a little bit of a primer on why and when it makes sense to use.
So I think this is kind of why WebRTC is magical. So there's this, imagine you think about like the fact that you have two computers and anywhere in the world and they want to talk to each other. And there's many different routes they could talk to each other. Imagine you're in the same network, or imagine that, you're talking to a different server, or you give a list of servers, one is in Europe, one is in North America. And WebRTC lets me constantly evaluate which connection is better. And the magic there is like, how do you define which connection is better? Is it like what's fastest? Is it what has the most least packet loss? Like all of these heuristics. And if you go and look at like Google Congestion Control or Scream or Nada or stuff like that, it says like, oh, we'll ramp up the bit rate, and then when we notice things slow down, then we'll like lower your bit rate. If you're on like a conference call and you notice how things are going in and out and changing, there's all of these heuristics and magic that's happening, and that's like why WebRTC is so great for these use cases, because you can't just sit down and say, okay, I'm going to upload a megabyte a second of audio or video and everything will just be fine. Like the world is constantly changing. Like someone in the same network as you decides to start torrenting or something like that and it destroys your connection, but WebRTC will dynamically adjust and look for those things. So for me, like WebRTC lets me do all these things. The WebRTC is solving all these things that you're not going to realize until you hit it in production. And then also, I think WebRTC will let us do interesting things in the future, like we'll run models in your LAN and stuff like that, and they'll find each other because they can use ICE to like pick out and like find the fastest route to each other. Like I don't know. What's cool to me is that WebRTC is solving all of these real-time audio and video problems that we've known for 30 years, and it's a shame to kind of throw them away. I hope that as more and more people come to this space, that they can look at look one layer lower and be like, oh, this is the complexity, and like I don't want to deal with this. So that's what's exciting to me about it, like what it solves.
I know the first time I touched it, Aleix and I worked at Quinn's previous company, Oblong Industries, and we started playing around with WebRTC in 2015. I remember thinking it was magic. I thought, how the hell does this thing work? Like, it's just, at the time you had to install browser extensions and all sorts of things. Now it's become native to the browsers, but it's really, it's changed. What have you seen in your time?
So before WebRTC, we used to use another protocol which is called RTSP, which is for video streaming. And RTSP uses RTP packets, or the RTP protocol, which is on top of UDP. And then we had to figure out forward error correction if there's packet loss, adjusting the bit rate dynamically. And then when WebRTC came out, we were like, wait a second, WebRTC solves forward error correction, it solves encryption, it solves all these things that we had to solve. And now it's like this, they put a bunch of old protocols from the 90s, like RTP, I think it's from 98 or something like that. And they grabbed all these protocols together and they made a standard out of it. And it, yeah, John was saying, just solves all the bunch of hard work that has taken many years to figure out how to do. And it's just now available in the browser, which is amazing. In the browser or any microcontrollers now, which is fantastic.
Yeah, we actually have Varun over here from Daily, who is one of the main contributors to WebRTC. So if you have any deep questions, these two or three are the guys to talk to. So I guess to maybe start to segue a little bit more into voice AI. So Sean is responsible largely for the real-time API, OpenAI's real-time API. So I guess given your background in WebRTC, what did you bring from that background into building the APIs? What considerations did you have? Developer control, how much flexibility, how much complexity to kind of unveil?
What was really important to me is I wanted to be as simple as possible to use, and for two reasons. I wanted it to be easy for people to use. It was really important to me that you could sit down and write in just 15 lines of JavaScript and connect to it and hear that voice come across, and that was really magical to me. The other thing that was really important is I wanted it to be available for newer platforms. So OBS, like the broadcasting software, added WebRTC in the last year. And so imagine if streamers or someone else can point OBS at a WebRTC endpoint and do like analysis of it. I also wanted to keep it simple, have the WebRTC at OpenAI be really simple so that you could do microcontrollers at it. I think voice is going to get really magical when it kind of enters the physical realm. Imagine if any developer can go and buy a little microcontroller for $20 off Amazon and put it around their house, and when you walk in your kitchen, it knows that it's primed to know that you're going to talk about recipes, or when you go to the other room that you're going to talk about music, and all these things. And I just want to make it as easy as possible for people to use and make it accessible in the most platforms. OBS, FFmpeg, because I don't know, that's what I love. I just love enabling people to build interesting things as possible. And the less I assume and the more easy I make it for people to build things, the better that it is. And it's hard when you've been doing this for so long, you think about all the edge cases and you're like, I got to build this giant API that's bulletproof. But if you can peel it back and make it simple and be like, okay, I'm going to miss some edge cases, it ends up being a lot better.
Yeah, it's, I don't know, Aleix, do you have any thoughts on that? You can even look at it from, maybe, I guess to draw a parallel is building WebRTC APIs for voice AI APIs. Any considerations or parallels there? Things that are similar, different?
I guess in Pipecat, when you Pipecat. Oh, sorry about that. Yeah, Pipecat is, as I was saying, this orchestration layer, and it has different transport. The transports are how you get audio into the system or how you get audio outside of the system. Audio or video, it doesn't matter. And we are, like Pipecat, for example, is transport agnostic, so you can plug in WebRTC, you can plug in WebSockets, you can use any transport. You can even, a transport could even be a file system if you want it. So yeah, for like WebRTC again allows you to control things. For example, it allows you to do like low latency compared to WebSockets, for example. So that's one of the things I would say. Yeah.
I want to switch gears. Sean, we met earlier today, and we talked a bit about protocols. So I'm interested in maybe learning a little bit about, you were kind of, it sounded like enamored with WIP, the new protocol, and had a lot to say on microcontrollers. So I think this provides an interesting entry point to a lot of new use cases. Obviously, we're talking about voice. Voice is kind of the main modality currently, but obviously multimodality is the next thing. You talked about it briefly with cameras everywhere. I have some insights. We've seen really amazing demos where you have an agent watching your computer screen or watching your gaming screen. So where do you see these standards fitting in? And you feel free to drop things about microcontrollers too. I'd love to hear more about that.
Okay, so when WebRTC first came out, it didn't dictate how you connect things together. Basically, like each side would generate an offer and one side would generate an answer, and it was up to you to get them back and forth. And so you had this problem of like some companies, they would start the WebRTC session by like exchanging over WebSockets. Some would do it over HTTP. Some would, you could do it over a QR code. Like none of that, like all of that was left to you. This new standard that had come out, WIP, now dictates that like one way to do WebRTC is that you exchange this offer answer, or like Bootstrap to start basically to move from to connect these two WebRTC agents over HTTP. And here's where it's really cool, is now I can get WebRTC into things like OBS, where I can just plug in a URL. Now I can get things into GStream, and now I can get things into microcontroller. Like you're not writing any code anymore, you're just putting in a URL. The other thing I want to see is that if both, if you imagine two conference providers support WIP, that I can connect, two arbitrary services together. So like I envision a world where like, AI providers and conferencing providers can just connect directly to each other instead of having to like slurp and like do all this translation back and forth. Like my hope here, I just want to make things as easy as possible for developers to build interesting things and plug them together. So using these like open interoperable standards, just let people do all these creative, interesting things. And same with like them. Yeah, it's a very interesting future. Like the more you let people do things on their own, the more things you're going to see. That's my hope.
Very cool. So so we've seen, I'd say voice AI, this is switching gears a little bit. Voice AI has definitely been cutting its teeth on the phone. So I know a lot of folks, I think Dan, your use case is absolutely phone based. I think we see building Pipecat apps probably 80%, but I do see with WebRTC, WIP, video in particular, there's a lot of like new possibilities. I'm interested in getting the take from both of you on what you see coming, provided kind of this acceleration with new standard, like merged standards like WIP, and then these models becoming, especially multimodal, like the latest Gemini model and OpenAI real-time, provide a really interesting opportunity for new things. So interested to see where you think is going in like the next 12 months.
I've seen, and we've done demos actually about this. Like, for example, you have you have an editor and you're coding something, and then you have an LLM just watching the screen and telling you, you can't talk to the LLM and just it would recommend things. Or another example that I've seen is like you're playing a video game, and then the LLM is recommending things like, oh, maybe you should go this way, or maybe you should go this other way. There's like really, I don't know, it's really exciting use cases. Like right now, everyone is focused on phone calls and, just making, I guess it's the use cases that will bring like immediate value and business to people. But in the long term, I can see like video avatars, for example, like real time. And there's a few companies over that, like Taboo, Simly, and there's a few others. But real time video avatars with lip syncing, the game engines, for example, or even video games. Like I can imagine like video games. It's not video, but it's like imagine like a character. You're in a video game, and there's a character that the voice is like generated by an AI, and then it's lip syncing, and then you can talk to it. And every time you talk to that character, it just says something different, and then it will again. You will look at it in 3D, and it will just behave, um, like a real person. And that's more like not video, but even like more, more models, like gestures. There's a lot of cool stuff that is going to happen.
Right. I mean, we've seen things like this with NVIDIA is pushing the envelope. Obviously, like
Yeah.
very dominant in gaming. Really interesting things. Sean, what do you see coming?
I am very excited for when we get video into play here. So like if I want to be able to upload video to an API and it will tell me, and it'll be, it's not generative AI, but be able to analyze and tell me what it sees. I'm very excited about these to get voice AI into like the physical realm. So like right now you have to pick up the phone or you have to use an app, and I'm very excited. Like I built this little reindeer toy, and my daughter ran up to it and she talks to it and she thinks it's hilarious, and she's 4, and it pronounces her name wrong, and she's just she thinks it's hilarious. And just to think like there's an entire world, like it's a very small world in San Francisco where like we all feel comfortable using this technology, but if all of a sudden we can break it out and get it into physical devices, like how cool would it be to go to a museum and to talk to something that's hooked up to a microcontroller that is multilingual, that can tell you where an exhibit it is and you can talk to it. I think that's where it starts to get magical. And so my hope is that if I can get WebRTC into as many places as possible, all of the really, really smart linguistics, AI researchers, which I'm not, like my job is to just make it as accessible as possible. So that's like the thing that I'm like chasing after as hard as I can, is like, how can I get it into all these cool places, and then everything will fall into place. So that's the dream I'm chasing.
That's cool. Very cool. We've done a bunch of experimentation with Pipecat, and I was just sitting here thinking, we were talking earlier today how we've built out a bunch of examples, and it seems like some of these examples, one of which was a study pal. So you can upload any type of knowledge base or store to it and talk to it about something. It just provides a novel experience. And it feels like we're just at a time where you could stumble into like the next giant product. Like I feel like if you went into the Pipecat examples repo, you could probably find free products that should be companies. So it's just a really exciting time to be doing things. So I guess maybe to end, just interested in what you guys are hacking on this year. Obviously, you're working on Pipecat, but anything you're excited to do this year? Maybe in personal projects, maybe work aside, if there's time. Aleix.
There's my Pipecat to-do list. It's like so big that I don't even know if I'll have time to finish it. But in terms of Pipecat, which is what I'm hacking like day and night, I would love to improve observability. There's a lot of people have issues like understanding, because it's an orchestration layer framework, right? You have the TTS, and you have the speech to text, and you have the LLM, and you have an audio recorder, and you have another thing that saves the transcription into files. And when it doesn't work, it's like, oh my God, like like you don't even know how to start debugging things or know what's going on. So I've been talking to Mark about this. Is like one of the things I want to do, and I keep delaying, is adding a good way for people to, open a web debugger or a terminal debugger or something. Say, okay, I'm gonna click this element or this processor, and I'm gonna check what happened to it, like in the history of this conversation. There's a lot of tools. Actually, today we were talking with the company that allows you to look at what the LLM said, and what a little bit, you have a little bit of observability, but the one we think about is like more like deep level. Like imagine like in network, if you learn a lot of network stuff, there's a tool called Wireshark that you'll see all the packets that go through the network, and you click and you can see all the data and how they relate to each other. So something like this, but for Pipecat. That's my dream or my vision. That's one of the things. The other thing is like I also told Mark. Right now, Pipecat is very easy. It's like a one-to-one use case. That's what it provides, and the many-to-many use case, which is a bit weird. I still have to find use cases, but I can see in the future world where there's multiple participants in the call, and also multiple bots at the same time. And bots can have like audio, real-time audio, and real-time video at the same time. So that is my vision.
Sean?
So the windmill I've been tilting at is making broadcasting easier. So about 2 years ago, I added WebRTC support to OBS. And the reason this is cool is because right now when you do broadcast video, there's like this delay. Like you send something to the broadcaster and you wait 2 seconds for him to respond. And it's very disassociative. It's like this, parasocial relationship where like, it's they take their time. But I loved, I watch all these people that are on Discord and in like this project called Broadcast Box where they're like talking to the audience directly, and it's like it's like sitting on the couch next to someone. And for me, this feels like, oh, this is my chance to make a little bit of a better future for people. And it does all these things, like you can generate your transcodes in OBS, and so it becomes super cheap to host. Like one of the things that is, it's very hard to make a new broadcasting competitor because you have to have all these servers to generate the renditions or the ladders or whatever you want to call them. And now that's all put into OBS, and so it makes it dramatically cheaper. So this isn't the right audience to pitch to how cool this is, but this has been the thing that I've been chasing after for a while. That really excites me. And then I'm very excited for, I really want to finish a pure Go network simulator. So there's like network simulators out there, but they're very hard and you load them up and do. So I want to write one in Go where I can simulate like packet loss and packet congestion, so I can say like as like the buffer gets more bloated, it delays, and then write it in Go and then spit out a shared object. So then you can use it in anything. You can do like an LD preload and then be able to like do it in all the other programs and make it as easy as possible. So those are the two that always sit in the back of my, like when I'm on a long flight, I'm like, this is the time I'm going to sit down and do this, but then I end up doing other stuff. Those are the two windmills that like I think about.
Maybe tomorrow.
So it'll be, tomorrow's the day. This is finally motivates me.
Could be the day.
It's been years that like I've always like, this is the thing. But then like I look at my inbox, I'm like, all these GitHub issues. They're like, this is crashing, this is broken. I'm like, I can't ignore these. So I don't know. Tomorrow. Yeah, tomorrow's the day.
My kids really need the OBS stuff because I was telling them this morning that one time I saw them, they were looking at YouTube or Twitch or whatever, a streamer, and they wanted to play. There's a game called Fall Guys, and they wanted to play in the same session that this guy was playing, and they were just counting like 5, 4, 3. Like, what are you doing? He's like, no, it's the delay of when he talk and then when I should join. I said, okay, like if we had WebRTC OBS, then that would be solved like right away.
Yeah, and then it's just like when it's WebRTC, then you can pull other people's videos into, since it's all WebRTC, you can pull your friends into the video, and also you don't need to install broadcast software. Like I love that it would give all these new voices to people. You have like broadcasting is very, technical centric. Like the fact that you have to download software and talk about bit rates and stuff like that. Like if I could just open up my browser and like start talking to people and talk about the things that matter to me. So
It's inherently one-to-many too. I mean, you get simulcast with WebRTC and all sorts of flexibility, real time. Yeah.
So you got to cut me off because I'll just keep.
I was going to say we're running long, so thanks to these two for coming, and thanks for everyone for listening. We're going to have, I don't know how long we run till tonight for networking. Another hour till about 9. So feel free to hang out. The pizza might be gone, but there are a lot of folks here, so feel free to meet each other. Thanks so much. All right, good job.